Hello and welcome to A-Level Math. We have covered so far the concepts of permutations, and combinations is somewhat like permutations, but it it is somewhat different as well for permutations, and this is what we are going to cover in this video. We'll start with the idea and intuition of combination, and we'll understand how combinations, the questions on combinations, differ from the concept of permutation, and then finally we'll take up some numerical examples. So if you haven't seen the videos on permutation, please click on the I button above, because it is very important to understand the concepts of permutations before diving into this concept of combination. So let's get started. Assume that we again have the 5 balls. Remember, these are the same 5 balls that we had in permutations. So in permutations we were concerned with the arrangement of these 5 balls. So suppose we are given these 5 balls, and the total number of ways in which we can arrange these 5 balls was 5 factorial, which is 5 times 4 times 3 times 2 times 1, which was 120. So permutation effectively means arrangement of something. So if you change the position of these balls, say for example if you take the red ball here and the green ball here and make any possible changes, like you can change the position of any of the balls, then that is what is permutation. Permutation means arrangement. In how many ways you can arrange given some things. But for combination, it is not the arrangement, it is the selection. So permutation means arrangement and combination means selection. So selection of what? Suppose I have these 5 balls and I want to choose 3 balls out of these 5 balls. So in how many ways I can choose 3 balls out of these 5 balls? Say for example I can choose these 3 balls, or I can choose these 3 balls, or I can choose these 3 balls. I can choose any combination of the balls, right? So in how many ways I can make such selection? How many such selections will be there? So let us assume that there will be x number of selections. Now we have assumed that in all we can make x selection. Say for example if we have one particular selection, say for example if we select these 3 balls, then for this particular selection we can have 3 factorial ways in which we can rearrange those balls, right? So I'm just telling you, I mean this has nothing to do with combinations, because rearranging will be something like permutation, but just to find out the answer we'll use the concepts of permutation, and you'll soon understand why. So assume that there are in all x many selections. So for each and every such selection I have 3 factorial many arrangements for them. Say for example if I choose these 3 balls, then this selection will give me 3 factorial number of arrangements. I can arrange these 3 balls in 3 places in 3 factorial ways. So for x selections, in all I will be having x times 3 factorial many arrangements, and this is effectively 5p3, because 5p3 is nothing but the arrangement of 3 balls out of 5 balls. Remember, that is what the concept of permutation was. So make sure you are very clear about the concepts of permutations. So permutation means, actually permutation is 5p3 is like selecting 3 balls first and then rearranging them, and this is the idea that we are using over here. So if we assume that there are x selections that we can make, then for each and every such selection we can have 3 factorial arrangements for them. So in all we can have these many arrangements for 3 balls taken out of these 5 balls, which is effectively 5p3. So x becomes 5p3 divided by 3 factorial, and this is what is known as 5c3. So the number of selections of 3 balls out of 5 balls is this, which is denoted as this. So if suppose instead of 5 balls you have 10 balls, and I ask you in how many ways you can select 6 balls out of these 10 balls, so your answer will be 10c6. And how do you evaluate 10c6? You will say I will find out 10p6 and then divided by 6 factorial. So in general, if I give you n many balls and I ask you to find out how many selections of R balls you can make, then your answer will be, okay, I will first find out NPR and then divided by r factorial. This is what is the concept of combination. This is the very fundamental formula for combination using permutations. Okay, so you remember, if we were given 10p3, then I told you that you start with 10 and then go 3 steps down. So 10 times 9 times 8, so that is 10p3. So similarly, if I ask you to find out 10c3, you'll have to first write down 10p3 and then divide it by 3 factorial. I'm sorry, it's an addition. You have to divide by this factorial in the denominator. Okay, so now there is one more formula. Remember, npr is equal to n factorial by n minus r factorial. This was the formula of npr. So if you just put down this formula over here, then we have one more formula for ncr, which is n factorial by n minus r factorial times r factorial. We have just put down the formula for npr, and then in the denominator we have kept an additional r factorial, and this is also a formula. So it's upon you. If you want to use this formula, you can do that. If you want to go this way, first find out npr and then divide by r factorial, you can do it that way also. So that's your discretion. Okay, so let's take up a question. We will evaluate 11c4. So 11c4, I'll use the first method. So I'll write it as 11p4 by 4 factorial. So what is 11p4? It is starting with 11 and then going down 4 steps. So 11, 10, 9 and 8, and then divided by 4 factorial, which is 11 times 10 times 9 times 8. 4 factorial is 24, and this is 8 3s are 24, and this is 3 3s are 9. So I get the answer as 330. Remember that whenever you are simplifying any such combination value, say for example in this case 11c4, or it can be anything, just make sure that the answer is always a natural number, be it p or be it c, be it a concept of permutation, be it a concept of combination. All these values, 11c4, 11p4, 10p5, 10c8, 11c something something something, all of these will always give you a natural number as your answer. You cannot have a negative number, you cannot have a fraction or a decimal as your answer, because these are the number of selections. Number of selections or the number of arrangements in case of permutations can never be negative, and they can never be fractions or decimals as well. They have to be natural numbers. You cannot have arrangements of 3.5 ways. You cannot arrange something in 7 by 10 ways. It always has to be some natural number, right? Okay, so let's recap a bit. NCR is n factorial by r factorial n minus r factorial, which can also be expanded to this. I leave it to you as an exercise. You can refer any standard textbook and you will find out how we are reducing it from here. And NCN is NPN by n factorial, right? Now remember, what is NPN? NPN is n factorial, and then divided by n factorial, it gives you 1. Alright, but this is something that we have to understand. Why is NCN equal to NC0? Okay, we have found out that it is actually equal to 1, but this thing NCN is NC0. This I'll tell you in just a moment. Please bear with me. And now finally NCR is NPR by r factorial. This we have done. Okay, now suppose I again give you some balls. Assume I give you 5 balls. These 5 balls are different. Then I ask you in how many ways you can select 3 balls out of these 5 balls. So that combination is given by 5c3. Now this 5c3 is also equal to 5c2. Why? Okay, let me tell you. Let's think about this question as something like this. You have 5 balls, and then you divide this 5 ball into 2 parts. I mean, you are to select 3 balls out of these 5 balls, and then whatever remains is suppose selected by your brother. So say for example, you have 5 balls. I repeat myself to make it even clearer. You have 5 balls, and then I ask you in how many ways you can select 3 balls out of these 5 balls. So if you are making a selection of 3 balls every time, then 2 balls are left in each of those selections. And it is very much clear, every time you make a selection of 3 balls, all of those times 2 ball has to remain there. They will remain somewhere. I mean, you selected 3 balls, then 2 balls are left over. So the number of selections of 3 balls or the number of selections of 2 balls is actually equal. Okay, because each and every time you select 3 balls, 2 balls are automatically selected by someone else, or they are left over. So are you understanding? So this is why 5C3 is equal to 5C3. In general, NCR is equal to NC n minus R, because every time you make a selection of R balls out of N balls, then N minus R balls are left over, and they will give you other type of selection. Okay, so this one formula you have to remember as well, that NCR is NC n minus R, and this is what they have applied over here. NCN is equal to NC n minus n, which is NC0. This is what they have used over here, and this is really important. Okay, this is a very well known and important fact. Alright, let's use those things to find out these values. You are given that NC18 is equal to NC12. So you see, N is N over here, and 18 and 12. So 18 cannot be equal to 12, right? So what do? We write NC12 as NC n minus 12. We can do that because every time you are selecting 12 balls out of N balls, or anything, not just balls, then N minus 12 things are left over, and they are the same number of selections. They will give you the same number of selections. Okay, so now we can equate these two. 18 must be equal to N minus 12. So 18 is equal to N minus 12. So we have 18 plus 12 is equal to N, which actually gives us 30. So N is equal to 30. And now they have asked you to find out 32CN. We have already found out N. So let's find out 32C30. So there are two ways of doing it. So you can either start with 32 and then go 30 steps down, divided by 30 factorial, and there is even a shortcut. So we won't use this. We will use the same formula, like 32C30 is actually equal to 32C32 minus 30, right? This is just now we have discussed. So 32C2, and now it becomes easier to solve. So starting with 32 and then going down 2 steps, so 32 times 31, and then divided by 2 factorial, which is actually 2. So 2, 16, and then 16 times 31 is 6 1s are 6, 6 3s are 18, 19, 1, 4. 496 is our answer. Alright, you please verify. I might be doing some small mistakes. Okay, let's take up another question. This, if 10CR is equal to 10CR plus 4, then find out 5CR. Okay, so let's start with what we have at hand. 10CR is 10CR plus 4. Now R can be equal to R plus 4. This is one choice. Let's see what we get. R equal to R plus 4 gives us R and R cancels out, so we are left with 0 equal to 4, which is of course never possible. It cannot happen. So this is not the correct way of doing it. What do? We write this 10CR plus 4 as 10C 10 minus R plus 4, and then now we can equate this. So you have to see which one holds true. You have to try both. Initially it was very much clear 18 can not be equal to 12, so that is why we straight away omitted that. But if you have any problem, you can go and equate that, just like we have done it over here. If you find that something you are getting is something that is impossible, ignore that and do the other way around. So now we have 10CR plus 4 is 10C 10 minus R plus 4, and now we can equate R with this thing. Okay, so we can equate R with 10 minus R plus 4, so we get R equal to 10 minus R minus 4. Now R comes over here, so 2R is equal to 10 minus 4 gives us 6, so R is equal to 3. And then we have to find out 5CR. So 5CR is equal to 5C3, which is 5 times 4 times 3 divided by 3 factorial, which is 6. So 3 2 2 2, and then it is 10 as the answer. Again we have a similar problem, so you try it out yourself. I leave this to you as an exercise. Alright, this is really important. I'm telling you, it's like not in just combinations. You will use this formula in many other places. So we will prove it, and then it is good for you if you memorize this formula. We will of course prove it for now so that we understand combinations better, but it is even better if you remember this formula, because not in just combinations, you will be using this formula in many other chapters as well. They sometimes in schools they sometimes mix math some chapters. Okay, so let's start with the left hand side. So in the left hand side we have NCR by NCR minus 1. So we open up in the formula that we know. NCR is n factorial by r factorial n minus r factorial divided by NCR minus 1 will be n factorial r minus 1 factorial n minus r plus 1 factorial. So just we have, in place of r we have r minus 1, so it is n factorial by this thing factorial into this minus this factorial. So that is why we are having such result. You verified yourself. Now we multiply with the reciprocal of the denominator and see what we have. N factorial by r factorial n minus r factorial, and now reciprocal of the denominator. So r minus 1 factorial n minus r, it will be n minus r plus 1 factorial divided by n factorial. So n factorial cancels out. N minus r plus 1 factorial can be written as n minus r plus 1 factorial. Sorry, it can be written as n minus r plus 1 into n minus r factorial. Remember, we used to do 10 factorial is 10 times 9 factorial, or sometimes like 10 factorial is 10 times 9 times 8 factorial. So this is what we use. So n minus r plus 1 factorial is n minus r plus 1 and then multiplied by 1 minus factorial. So we subtract 1 out of it and then factorial, and then we can write this r factorial as r times r minus 1 factorial, and then we are left with n minus r plus 1. We are left with so we have r minus 1 factorial and n minus r factorial. These are the things that we are left with. So n minus r factorial cancels out with this, and r minus 1 factorial cancels out with this, and finally what we are left with is n minus r plus 1 divided by r, and this is what was required to be proved. Okay, so in a similar way you can try and prove this result yourself. So this is an exercise for you, and it's just to recap. NCR is NCn minus r. NCx, if NCx is equal to NCy, then x plus y is equal to n. This is nothing but a deduction from the previous one. So if NCx is equal to NCy, and they told you that x is not equal to y, so x is not equal to y. If they tell you that this thing holds, then we have NCx is equal to NCn minus y. So we have x is equal to n minus y, and this gives us x plus y is equal to n. So this is nothing but a deduction from the previous one itself. So you may try to remember this, and this one is really important. Another formula, you will also use this formula very often, so I'll just prove it in the next slide. And this we have something like this we have proved just now, so you can also give it a try. NCR minus 1 by n minus r cr minus 1 is this thing, so you can give it a try, and this is just now we have discussed. I hope you have done it. And this is another formula. These are just for practice purposes. You can try them. You must actually, if you really want to understand these things. So let's prove the Pascal's rule now. It is asking you to prove NCR is plus NCR minus 1 is actually n plus 1 CR. Okay, so let's expand this. NCR is n factorial by r factorial n minus r factorial plus NCR minus 1 is n factorial by r minus 1 factorial and n minus r plus 1 factorial. Okay, so let's find out what's the LCM. So the LCM is r factorial into n minus r plus 1 factorial. So initially we are left, we can take n factorial common throughout. So now let's see what is left with, what we are left with. So we are having r factorial, so it's not needed. Then we are left with n minus r plus 1 over here, and plus this is here, and minus r plus 1 factorial is here. So we are left with r, because r times r minus 1 factorial will be r factorial, right? Okay, now what we are left with is n factorial minus r plus r gets cancelled out, so n plus 1 is what we are left with, divided by r factorial n minus r plus 1 factorial. So this n factorial times n plus 1 is n plus 1 factorial divided by r factorial, and then we can write this n minus r plus 1 as n plus 1 minus r factorial. So this is nothing, if you observe, is n plus 1 cr, because n plus 1 cr is this factorial by this factorial into this minus this factorial. So this is effectively n plus 1 cr. Okay, so this is the mathematical proof, but this also has an intuitive proof as well. Now what is the intuitive proof? Assume that you are given n plus 1 of something. Suppose that you are given n plus 1 mini balls, and if I ask you to make two types of selection, I give you n plus 1 mini balls and ask you, hey, you have to select you have to select r balls out of these n plus 1 balls. Okay, let's take an example to understand this better. Assume that I give you 10c3. So I give you 10c3, and that means that I have 10 balls, and I ask you to select 3 balls out of it. Now I give you that there is a particular ball which has always to be selected. So there is a particular ball which always needs to be selected. So what you do, you take that ball outside and always keep that with you, and then out of the remaining 9 balls you select remaining 2 balls. Okay, so if you want to always have one particular ball, this is the number of selections which you can make out of 10 balls for selecting 3 balls. So if I ask you that, hey, you have to make selection of 3 balls out of 10 balls, but one particular ball should always be there, then the number of selections is 9c2. And now if I ask you to make such a selection that particular ball is never there, so if I ask you, hey, you have to select 3 balls out of 10 balls such that one particular ball is never there, so what do? You pick up the ball and throw it away, and then what you have to do is effectively out of the remaining 9 balls you have to select 3 balls, because that ball should not be included, but you have to select 3 balls. So if you add these two, what are these two? If you add these two, they say that this is the total number of selection where one ball is either there or it is not there. So it is actually the total number of selections of 3 balls out of 10 balls. The total number of selections of 3 balls out of 10 balls is the sum of 2 selections, where one selection says that, hey, one particular ball is never there, and other says that one particular ball is always there. So if you add those things up, then you should be actually getting the total number of selections that can be made from 10 balls for 3 balls. Okay, that is the intuition behind it. Mathematically you can also do it like this, but intuitively it has some meaning as well. Alright, we are given two relations, NPR is equal to NPR plus 1 and NCR is equal to NCR minus 1, and then you have to find out the values of N and R. Okay, so let's try. So if NPR is equal to NP R plus 1, then okay, we cannot have N is equal to R or R equal to R plus 1, because this will give us 0 equal to 1. Let's start with this. NCR is equal to NCR minus 1. So we cannot have also R is equal to R minus 1. So what we do? We write this denominator, or I mean whatever is there, as N minus R plus 1, and then we can equate R with this thing. So we have R is equal to N minus R plus 1, and we take R here, so we get 2R is equal to N plus 1, and this is our first equation. Alright, okay, now what about these? So let's see what we can do with this result. We know that NCR is equal to NPR by R factorial. We actually don't need this. What we do, we just expand these. So we start with NPR is equal to NP R plus 1, and so we have N factorial by N minus R factorial is equal to n factorial by n minus r minus 1 factorial. Now n factorial is cancelling out. So n minus r minus 1 factorial is n minus r factorial. So we can write this down as n minus r minus 1 factorial is equal to n minus r and then subtracted 1 factorial. Now these two cancel out, so we have 1 left over here. So we have 1 is equal to n minus r, and this is our equation number 2. So we have two equations in terms of two variables, n and r. So we can solve these two to find out the values of n and r. So we find out the value of n from here. So n is equal to 2r minus 1, and here we get n is equal to r plus 1. So what we have is r plus 1 is 2r minus 1, and 2r minus r is here r, and r is equal to 2, and putting it over here we get n is equal to 3. So these are the values of n and r. So I have solved it. You may also try it yourself in any other way by using elimination or anything. I have used comparison over here. Okay, so we have got the values. Now next question. N plus 2 C8 is 2, n minus 2 P4 is equal to 57 is to 16, find n. Okay, so let's expand it. N plus 2 C8 is this factorial by this factorial into this minus this factorial, and n minus 2 P4 is this factorial divided by this minus this factorial. This is 2, and this is equal to 57 is to 16. Okay, now we can convert this ratio into multiplication, and then we can reciprocal this. So we can multiply with the reciprocal of this because it will be a fraction, and then we can multiply it. So we have n plus 2 factorial by 8 factorial times n plus 2 minus 8 is n minus 6 factorial multiplied by n minus 6 factorial divided by n minus 2 factorial. So we have converted this ratio into multiplication and multiplied with the reciprocal of this thing. Okay, now n minus 6 factorial cancels out. We have 57 by 16. So n plus 2 factorial is n plus 2 subtracted 1, subtracted 1 more, subtracted 1 more, and then subtracted 1 more factorial divided by 8 factorial n minus 2 factorial is equal to 57 upon 16. So we have used that result, n plus 2 factorial. Suppose we have 10 factorial, that is can be written as 10 into 9 into 8 into 7. We can go any steps and then write down 5 factorial. So 10 times 9 times 8 times 6 times 5 factorial. We can expand it like that because 5 factorial is 5 into 4 into 3 into 2 into 1. So that is contained inside 5 factorial. So you can write it any way you want. Okay. So this is what we have used over here. N plus 2 is we go on subtracting it, and then we can just stop subtracting and then put down factorial. Okay, so this is the advantage of doing that. And finally what we are left with is n plus 2 times n plus 1 times n minus 1 divided by 8 factorial. 8 factorial is 8 times 7 times 6 times 5 times 4 factorial, which is 24. 57 upon 16. So let's cancel out something. 4 6s are 24. 4 6s are 24, and 4 4s are 16. 4 2s are 8. So what we are left with is n plus 2. Okay, let me clean everything. Okay, this is what we are left with finally. So now let's take everything on the right hand side. We have n plus 2 times n plus 1 times n minus 1 is equal to 57 times 7 2s are 14. 14 times 5. Okay, 7 2s are 14 times 5 times 36. Okay, now if you notice, these are 4 consecutive numbers. These are 4 numbers like 7, 8, 9, 10, or like 10, 11, 12, 13. These are 4 consecutive numbers because n minus 1, n plus 1, n plus 2. These are 4 consecutive numbers. And this is a product something. So my aim is to convert this entire product into the product of 4 consecutive terms. Okay, so I'll have to think about it a little bit. So what we can do is, 57 a prime number? No, 57 is divisible by 3, right? So 57 is divisible by 3, so I can divide by 3 to give 3 1s are 3, 27, 3 9s are 27. So 57 can be written as 19 times 3. So let me write it down as that. 19 times 3 is 57 times 14 times 5 times 36 can be written as 12 3s are 36. Okay, so I think that I will be getting numbers somewhere near to 19, because 19 is a prime number and there is no way we can factorize it further. So my hunch is that I will be getting some numbers which are near to 19. I mean, the numbers could be 15, 16, 17, 18, or like 16, 17, 18, 19. I mean 17, 18, 19, 20. I'll be having somewhere 19. That is my hunch. So I'll try to convert this into some series of 4 consecutive natural numbers. So okay, 14 can be written down as 7 times 2. So I'll break everything further. So 19 times 3 times 14 is 2 into 7. Then 5 is a prime number. 12 is 2 into 2 into 3. Then into 3. Okay, so I'll try to convert things into numbers that are near to 19. So I have 19, I keep it as it is. Now 7 and 3's give me 21, so 21. Then this 2, 5 and 2, this gives me 20. 2 times 5 is 10, times 2 is 20. So 20, and then these 3 give me 18. So see, I have got 4 numbers which are consecutive. I get 18 times 19 times 20 times 21. So these are the 4 numbers, and they are equal to these 4 numbers. Okay, so you see which is the smallest number out of these, n minus 1, and which is the smallest out of these, 18. So I get n minus 1 is equal to 18, so I get n is equal to 19, and this is my answer. That's it. It was a small video just to give you a basic understanding and intuition of combinations. We'll take many word problems in the videos to come. So please stay tuned, and happy learning and study hard. Bye bye.